Hi there! In this video we're going to talk about multiplying rational expressions that are multivariate monomials. So multivariate means multiple variables, so you're just going to have more than one variable. And a monomial is like a single term, so nothing will be added or subtracted to it. So that's what that means. So what is this lesson asking us to do? Basically, we're just going to be multiplying some fractions with more than one variable, and we're going to learn how to properly simplify it as much as possible. So to do this, we're going to use the cross-canceling method. So it's based on the fact that we know that something, anything, divided by itself, like 10 divided by 10, is equal to 1. Or x divided by x is equal to 1. So we're going to use that concept to simplify our multiplication problems by either cross-canceling, or basically I want you to think of it as anything on the top is fair game to cancel with anything out on the bottom. Okay? So the first example that we're going to do, I'm actually going to write it all out so that you can see how this works. And then the second example, I'm going to kind of show you like the tricks that I would use when I do this. So when I'm multiplying this all out, I'm going to say, all right, my first one says 5 times A times A. And I also have times 4 times I have 3 x's. On my bottom, I have 6 times x. And then I have an A times A times A times x. That's what all that means. Okay, so I'm going to remember that anything divided by itself equals 1. So I can say that A divided by A, when we call this canceling each other out because it equals 1. And I also have this A, I can divide it by this A. I have no more A's to cancel out on the top. So this A right here kind of stays where it is. And what about X's? I have an X here that can cancel with this X. And I have an X here that can cancel with this X. So I have no more variables left to cancel. Now I can look at my numbers. I want to look at numbers on the top and the bottom, and I want to simplify my numbers by seeing what are numbers that can go into them. So like if I focus on 6 and 4, I'm going to ask myself, is there a number that goes into 6 and 4? So there is. 2 goes into 6 and 2 goes into 4. 2 goes into 6 3 times, and 2 goes into 4 2 times. This number here, I don't have anything that I can reduce it with, so it stays the way that it is. And now I multiply everything that I have left. So what do I have left? Let's see. Let me find a different color that I haven't used yet. Let's go orange highlighter. So I have a 5, I have a 2, and I have an x left on the top. So 5 times 2 is 10 times x. On the bottom, I have a 3 and an A. And this is my final answer. Okay, let's try the next one. So now on this one, I'm not going to write it all out. I'm going to do it the way that's a little bit faster. So on here, I'm going to do my numbers first this time. I'm going to say, okay, if I look at my number 5 and I look at my number 15, is there a number that goes into both 5 and 15? Yeah, 5. 5 goes into 5 once, and 5 goes into 15 3 times. Okay, what about my other numbers? I got my numbers, I have 4 and 2. Is there a number that goes into both 4 and 2? Yeah, 2 goes into 2 once, and 2 goes into 4 2 times. All right, now I'm going to look at some canceling out some of my variables. Here I have 1A here, and here I have 4 A's. So if I get rid of 1A on the bottom, that leaves me with 3 A's left on the top. And here, I have a B here and a B here. So I can say, well, a B over a B goes away. So now what am I left with? Okay, I have a 2 and times a 3, and then I have an A to the 3rd and a B to the 5th. And on the bottom, I have a 1 and a 1. 1 times 1. So my final answer would be 6a to the third, b to the fifth over 1, or anything over 1 is just itself. So my final answer would be 6a to the third, b to the fifth. Final answer. Okay, this one I want you to try on your own, and you can do it either way. You can either write it all out, I will do it both ways, or you can do it just the simplifying way that we did in example 2. So now's a good time to pause the video, try it on your own, and I'm going to work out the work for both of the methods that we just did. So I'm going to do the first method first. So I have 8 times y times 3 times b times y, and then I have a 9 times b times 4, and there are 3 y's here. So I'm gonna do my numbers first here. I have a 9 and a 3. 3 goes into both 9 and 3. 3 goes into 9 3 times. 3 goes into 3 once. I have an 8. Whoops. I have an 8 and a 4. 4 goes into both 4 and 8. 4 goes into 4 once, and 4 goes into 8 twice. And let's see, as far as my variables go, I have a y can cancel and a y can cancel. These y's can cancel, and then I have a b and a b that can cancel. So what am I left with? I have a 2 times a 1 on the top. And on the bottom, I have a 3 times a 1 times a y. So my final answer would be 2 over 3y. If you're going to do it with the not writing it all out method, I'm going to say I know that 3 goes into 9 and 1. And, 4 goes into 4 once and 8 twice. I have this b can cancel out with this b. And I have 2 y's on the top, so that can cancel with 2 y's on the bottom. So take these out and I get rid of 2 y's, which would leave me with 1 y. So what do I have left total? I have a 2 times 1 on the top and a 3 times 1 times y to the first. So this gives me 2 over 3y. Either way, oops, sorry, you can't see that the times. Either way, you end up with the same answer. And do whichever way is most comfortable for you. I happen to like the method that we did for problem number 2, but I've been doing this for a little bit. And if you like the method that we did for problem number 1, where we literally write it all out, it might be really helpful while you're learning. Well, let me know if you have any questions. Good luck.